1. Draw wiring diagram. 2. Set parameters of all symbols. 3. Run basic calculations to be sure that everything is correct. 3a. Voltage drop and load flow. 3b. Three-phase short circuit. 3c. One-phase short circuit. 3d. Hide results of last calculation. 4. Run the arc risk module, which is located in the All Calculations group. If arc risk is being launched for the first time, the password has to be filled in. The password is provided by EATON Technical Support. The arc risk dialog panel contains sections for calculation inputs. If you need more information about particular parameters, click on Details. Calculation results are incident energy and arc flash boundary. The incident energy is calculated for the specified working distance, usually 300 mm or 455 mm. The arc flash boundary is the distance to the point of the arc flash with incident energy of 5 joules per centimeter squared. The right bottom part of the panel shows information about maintenance mode and normal operation, each of them for different conditions, open doors or closed. The first option is the switchboard safety level tab. The second option is personal protective equipment level. And the third is the risk matrix. Let's start with the switchboard safety level option and select calculation inputs. Select the network node which the incident energy should be calculated for. Select the point where a short circuit occurs. The line side is the line side of the breaker or the fuse. The busbar side is on the load side of the protective device. Select the distribution board series. The X energy system is typically used up to 5000 amps with a high variety of sections. The X Energy Lite is the basic system for general use up to 2500 amps. Set the working distance, which is the distance between the person and the expected point of arc. Tip: read comments on the selected row from the property grid here. We will now focus on the group of protective measures used to reduce arc likelihood in switchboards. Set the switchboard's internal separation. Tip: read comments on the selected row from the property grid here. Set whether arc-free design is applied. This option is relevant for switchboards with fully insulated bus bars, like epoxy-coated insulated bars. Set whether temperature diagnostics are applied on the bus. This is a wireless system usable up to 150 degrees centigrade. Tip: read comments on the selected row from the property grid here. Another group comprises measures to reduce the thermal effect of arc flash. Set whether passive arc is applied. This option is applicable only for normal operation with closed doors. How to set the arms function. The arms function must be switched on. Activation, on or off, can be performed in the property grid of the selected circuit breaker or via tripping characteristics by setting the arms parameter. If arms is not activated and the circuit breaker is used with selective settings, then incident energy is very high. In this case, about E equals 600 joules per centimeter squared. To change arms settings, close the arc risk module. Open the tripping characteristics module to see the effect of the arms settings. Change arms property settings in the tripping characteristic module, or alternatively in the property grid. If arms is on, the switching time is significantly reduced. Close the tripping characteristics module. Launch the arc risk module again. And now we can compare the results with arms in off status, where incident energy was about 600 joules per centimeter squared, with activated arms on. In this new case, the incident energy is significantly lower, about 60 joules per centimeter squared. The respective value of arc flash boundary is also dramatically reduced. This is clear evidence that arms improves safety for personnel during maintenance work. Set whether ARCON is applied. Set the tripping time of the MV protection relay or the fuse. We can now demonstrate the influence of various measures on the switchboard safety level. Higher internal separation improves the switchboard safety level while normal operation is running. Arc-free design improves switchboard safety while maintenance is running. ARCON is the best solution which moves switchboard safety to the highest possible level in all cases. We can now demonstrate the influence of various measures on the personal protective equipment level. ARCON is the best solution which moves switchboard safety to the highest possible level in all cases. Final comparison will use the risk matrix, which provides the most complex information and is mainly used by safety managers. We can see that a higher internal separation level reduces the probability of arc. Arc-free design reduces the probability of arc to the lowest possible value. And finally, also that ARCON is the best solution which raises switchboard safety to the highest possible level.